Have you ever wondered how the most durable and reliable objects in the world are made? The RCC pipes, known for their strength and adaptability, but ever wondered how complicated the fabrication procedure is? Today you will understand the intricate process of their production, which in turn will make you more knowledgeable about their role in modern engineering. Do you know RCC pipes are much stronger than other types of pipes out there? They could also last for years. Reinforced cement concrete pipes are instrumental in creating new setups in the infrastructure and developmental sectors. These pipes are necessary for these projects as they provide basic amenities like water supply, an efficient drainage network, well-organized sewage disposals, and increased crop irrigation. RCC pipes are exceptional because they are quite durable and have the strength needed to endure the very tough conditions the environment throws at them, the various types of harsh weather, and the pressure of the soil. They can withstand protracted use without any considerable damage, making them a desired product in sustainability and a most important part of the community's progress and stability. The reinforced cement concrete pipes are designed to last despite exposure to high pressure, severe weather conditions, and heavy loads, proving more useful than traditional piping materials. The increased concentration of steel reinforcement, which directly strengthens the pipe's vitality, brings about its effective usage in the large items section. Even though their implementation underground, at the sides of highways, or in the industrial sector is quite demanding, RCC pipes still show unmatched reliability and performance, thus proving indispensable in places where durability and strength are of the utmost importance. The ability to work under pressure demonstrates their conformance with varying infrastructural project requirements, hence giving assurance to engineers and project managers. The RCC can extraordinarily resist rust and chemical corrosion compared to traditional metal pipes. This feature is a great asset for sewer and drainage systems in urban and industrial sectors because of the inevitable exposure to tough elements. They are not only sturdy but also long-lasting, which means fewer breakdowns or leaks. They are durable and reliable, keeping the infrastructure project in good shape. Despite the higher upfront cost of RCC pipes compared to other materials, their long-term advantages cannot be overestimated. The strong and durable pipes only need minimal maintenance, which consequently leads to a decreased number of costly replacements. This has been a plus for infrastructure costs over the years. The great quality of RCC pipes enables their integration into various infrastructure projects, including water distribution systems, agricultural irrigation solutions, and culverts. Each is essential to planning an effective urban area and providing rural development. Besides the practical side, the RCC pipes are 100% natural, making them the best new alternative in the market today. Their recycled nature also makes them the preferred choice for a renewable solution as they help reduce environmental contamination and simultaneously meet the high standards of modern infrastructure successfully, thus mitigating the hazardous effects of their demand. RCC pipes are essential foundations in the complex architecture of infrastructure and urban development. These robust conduits are steely pathways to water management and transportation systems. They are the main cogs required for the suburbanization of urban spaces. Their vigorous strength and impressive resistance to harsh weather and corrosion make RCC pipes stand out among other materials ordinarily designed and set up. They can perfectly bear the brunt of the elements and live through the troublesome environmental issues their surroundings face. These pipes garnered a reputation for their outstanding rust and structural resistance. Accordingly, these pipes will have a considerably lengthy lifespan, allowing people to feel secure in their systems. The most important aspect of their utility is that they are economical and thus play a primary role in the foundation. Without them, any other environmentally produced good has no value. These essential pipes will help create well-organized and durable communities, ensure economic sustainability, and promote close links between individuals. Thus, RCC pipes allow the easy transfer of energy, the final result being the flourishing of the cities and the enhancement of the quality of life. But how are these remarkable pipes made? You will soon find out. For now, let us consider the materials needed to make them. Cast reinforced cement concrete pipes must be done carefully to unite the high-quality ingredients needed in developing a strong, long-lasting, resilient material against environmental challenges. A very important ingredient in this operation is cement. Consequently, it is not surprising that the chosen cement may depend either on ordinary Portland cement or sulfate-resistant cement, which will depend on specific application requirements. This vital binding agent gives the mixture the structural integrity, resistance, and longevity it needs. This way, it can withstand the test of time and harsh environmental conditions. Another Another significant ingredient is the aggregate, coarse, and fine materials. Coarse aggregates, such as crushed stone or gravel, are primarily used to provide the necessary bulk and structural solidity. Fine aggregates, usually sand, obtain the desired smoother consistency mix. By working together, these materials decrease the shrinkage of the concrete and thus make it work as optimally as possible. In addition, reinforcement has an important role in the process, for which mild steel rebars, high tensile steel wires, and welded wire mesh may be used. This reinforcement gives the RCC pipes the required tensile strength, which would help prevent the formation of cracks and ensure that the pipes can bear the load and pressure without structural deterioration. The manufacturing process produces RCC pipes that are very strong, reliable, and thus readily applicable to large-scale engineering and construction projects through closely controlled selection and the right blending of materials. Water cannot be excluded when you think about the components for making reinforced cement concrete pipes. This must be pure and free from any impurities, chemicals, or organic matter that would harm the integrity of the concrete. The function of water is not limited to just mixing. Still, it is also a part of the process as it combines with cement particles into a hydrating product that guarantees the hardening is complete and the concrete is properly done. Admixtures are not necessary, but they can drastically improve the qualities of a concrete mixture. Some of these are plasticizers, which, if added, allow concrete to be more ductile and manageable and will not shrink or sulfate. Accelerators quicken the hardening process, while retarders prolong the setting time. This in turn gives room for application flexibility. Air entraining agents can also diminish concrete's susceptibility to freezing temperatures and chemicals, thus prolonging its lifespan. Steel or heavy-duty plastic molds and forms are also important. These are core components in forming aerated, light concrete to produce PVCs through its conversion to precise cylindrical pipe structures. The detailed combination of high-grade cement, aggregates that have been carefully chosen, correct reinforcement, and quality water, along with additives that have been individually fed into the system, turn them into the RCC pipes, which meet all the requirements. That is, strength, durability, and the performance benchmarks imposed by the infrastructure projects. The primary driver of the reliability of RCC pipes is that they are made of a thorough material selection and impressive quality control during the manufacturing process, thereby making the RCC pipes the ideal products for crucial functions. So now, how are these pipes made? The process is not that easy. Producing reinforced cement concrete pipes involves a systematic process to ensure durability, strength, and precision. Step 1. Raw materials are cautiously picked and properly prepared, producing perfect quality. Step 2. Mixing the raw materials is a precise process that gives the necessary strength and uniformity to the concrete. All the cement, sand, and aggregates are painstakingly measured in a calibrated batching plant, so every individual part is appropriate. The water is introduced gradually to create an even and well-blended mixture where all materials are implemented seamlessly. Moreover, if necessary, various chemical substances are put into the mixture to improve their workability, thus making them easier to handle and apply. This mix is prepared in a concrete mixer, a key batch processing activity that assures homogeneity. Employing an automated or manually operated concrete batching plant and a reliable concrete mixer is crucial to attaining the highest quality of the final product. Step 3. The reinforcing cage is a central factor in enhancing the RCC pipe's structural integrity. For the mold, this cage is composed of steel wires or bars, which are then cut and shaped to meet the precise specifications of the pipe. These steel parts are prepared accurately to be formed into a strong cylindrical framework, which can be accomplished by either welding or tying them together securely. Once the cage is completed, it is positioned within the pipe mold, giving appropriate support during curing. During this production stage, the machines used are reinforcement bending and cutting machines to obtain the proper shape of the steel, and spot welding machines for consistent bonding, ensuring maximum strength and resistance to the environment in the final product. Step 4. Casting of RCC pipes is the main stage of the construction process. The method of the spinning process for centrifugal casting is one of the most common. In this new approach, a durable reinforcement cage is rotated and fixed in a mold. During the spinning of the mold, the concrete mix, which is poured, has a high-speed rotation. A robust force is exerted uniformly, making the concrete disperse properly on the interior surface and removing the excess water. This activity makes a pipe that is impermeable, has a very high high strength and can withstand high pressures and environmental conditions. Another method is the vertical casting process. Here, a cylindrical steel mold stands to give room for an effective construction method. First, the reinforcement is placed inside the mold, then the concrete is introduced in layers. The first thing is to compact each layer with a special vibrator that squeezes the concrete tightly into the mold, and there will be no spaces left for air. After the compaction, the pipe is left to set and develop initial strength, ensuring its structure is strong enough. In producing such pipes during the stages of casting, spinning machines for centrifugal casting, vibrators for vertical casting, and tools like molds and formwork need to be used. All parts must be there to build the ultimate RCC pipes that are very robust and meet the structures and the project's high quality standards. Step 5. This stage is the curing process, one of the most important aspects that can increase the strength and durability of an RCC pipe to almost the maximum. After the process of pouring is completed, pipes are applied to the curing unit, which is fully managed and regulated. Water curing is done with the utmost care, either by careful spraying or immersion in large water tanks. In addition, steam curing is another possible way for quicker production, in which steam is used to speed up the process. The pipes are cured at a time ranging from 7 to 28 days, depending on the specific requirements, so that optimal structural integrity can be achieved. Step 6. After curing, the pipes are removed from their molds. Each pipe is carefully checked for quality. The detaching of the evolution process guarantees that pipes are removed from the molds uniformly and intact. On the other hand, the tubes are tested as soon as they are freed from their holdings. Stress testing that measures their durability under pressure constructs the pipe's quality, whereas dimensional tests confirm that they are manufactured according to strictly defined specifications. An elaborate surface review gives a glimpse of any imperfections that might lead to a decrease in the efficiency of the product. Hydraulic pressure tests are essential to ensure water tightness is achieved, thus ensuring the total reliability of the pipes. What they do at this important phase is hydraulic pressure testing machines that apply controlled forces to run simulations of real-world conditions and specialized tools and gauges that provide precise readings. Step 7. During the final stage, the pipes are expertly smoothed and prepared to be ready to deliver. Experienced operators use skilled hands to inspect the rough flanges to get a clean finished product. Each of the pipes is marked with necessary specifications to ensure that they comply with the standards provided by the industry, which will make identification clear and easy. Once the pipes are marked, they are placed in an orderly dry area that has been chosen, which protects them against moisture and damage before transportation. Thus, they are carefully stored. The machinery employed in this critical stage includes high-precision grinding and polishing tools. The advanced marking and labeling machines are also part of the assembly, which they zero in on to deliver a high-quality finished product. Step 8. Once the pipes have passed all the necessary quality control processes, they are carefully loaded onto the solid trucks, soon on their way to different construction sites where they will be installed. This stage is very important and requires heavy machines such as cranes and other lifting equipment, which all work together to ensure that each piece is transported securely. The trucks that drive the reliable transport routes are manufactured to handle heavy loads and navigate the roads, ensuring that the pipes will arrive in time and the best condition, and thus will be ready to be installed in the following stage of the construction. Having learned how RCC pipes are made, knowing some common misconceptions about them is essential. One of the common misconceptions is the idea that RCC pipes are brittle. Indeed, concrete might develop a few fine cracks on the surface due to the different loads and weather factors. Nevertheless, the fact about the strong RCC pipe reinforcement should be known, which includes the steel network that has been strengthened. The latter functions as a protection layer on steel, therefore the steel material has no cracks. Additionally, this driving reinforcement improves their tensile strength and allows them to be very resistant to any form of decay. As long as the best practice in terms of manufacture and curing is maintained, RCC pipes live an incredibly long life and show an unconditional stand. They stand up to torture and are an unshakable fortress. This unique key feature that differentiates their strength, civilization, or other sources of hardness may be a good reason to consider their choice for a wide range of applications, making them the best among other solid or durable construction and civil engineering options. Another prevailing misconception regarding reinforced cement concrete pipes is that their substantial weight makes their installation difficult and impractical. It is also a known fact that RCC pipes are a lot heavier than their plastic or metal alternatives. However, it is not just weight, but the main characteristic giving the pipes strength and long life. The latest powerful hoisting and installing equipment have marvelously handled transporting CCF pipes, which formerly seemed slow and cumbersome. The difficulties concerning the positioning and installation of RCC pipes have been significantly reduced due to the use of the latest technology. Therefore, installing RCC pipes is now simpler, combining an incredibly strong product and versatility, making it the best solution for various infrastructure needs. This sturdy and functional pipe contributes to the construction and civil engineering sector. RCC pipes are usually undervalued in terms of efficiency, particularly in the case of high-pressure applications. Nevertheless, contrary to many people's beliefs, these pipes are carefully designed and manufactured to be so strong that they can resist the pressures from both inside and outside. They are very good at sewage management, drainage systems, and high-pressure water supply networks. Their great load-bearing capacity makes them the top options for large-scale infrastructure projects, where they are made to be strong and flexible to ensure long-term operation. Another widespread delusion about reinforced cement concrete pipes is that they corrode easily due to poor material quality. Analogically, RCC pipes are like a lion compared to traditional metal piping and like a leopard, susceptible to rusting and destruction as time passes. These hardy pipes stand firm against attacks caused by rust, harsh chemicals, and damaged environmental conditions often found in wastewater management. Their outstanding stability makes them the perfect choice for drainage systems frequently exposed to tough and abrasive elements. Additionally, RCC pipes are generally considered expensive, a widely held belief. It is, in fact, true that the initial costs may exceed those of some other pipe materials, but this perception is based on a negligible factor: the long-run advantage afforded by these pipes. RCC pipes are one of the most cost-efficient solutions because of their superior durability and lower maintenance requirements. Their great durability results in their replacement being less frequent, thus saving money and other resources. A prevalent myth is that reinforced cement concrete pipes are very specific and you can hardly customize them. Still, the opposite is true. They are so flexible that even wonderfully made cannot contain the whole truth. RCC pipes, handsomely designed by hand, are available in different sizes, grades, and designs, including reliable spigot, socket joining, and robust collar joints. This remarkable diversity fosters an unprecedented malleability of the RCC pipes, allowing them to effectively satisfy the distinctive requirements of even the most complex infrastructure projects. RCC pipes emerge as a wide-ranging solution to urban drainage systems that occupy and adapt to the challenges of city landscapes and to water distribution networks that serve complete communities with serious competence. They can be manufactured to precise measurements needed in individual projects, making them adaptable to various areas. They also show they can be useful and suitable for different projects. Hence, they are perfectly designed for many applications that usually seem less challenging. The technology applied in designing RCC pipes to ensure their toughness and equality with civil engineering also opens up the market for developing new services that help solve current problems. Their strong and versatile ability makes them the ultimate assets in building sustainable and efficient infrastructure. Many individuals agree that RCC pipes have no green features, yet these pipes are made from natural materials such as cement, sand, and aggregates, making them eco-friendly. The material of RCC pipes enables them to be reused and repurposed in the next construction project. This way, their environmental effects are minimized. This trait encourages the building of ecological construction and supports the notion that eco-friendly practices can be combined with technical engineering solutions. Many false beliefs connected to RCC pipes can often be traced back to old data, or simply that people have not accurately understood their great abilities. These tubes are famous for their high strength, super adaptability, and excellent economy, putting them among the most necessary parts of contemporary infrastructure projects. By acquiring an in-depth knowledge of RCC pipes' multiple strengths, the planning team and engineers can make adequate, well-planned solutions focusing on long-term sustainability and reliability in their chosen construction solutions. Their superior construction method maintains their functionality under severe weather conditions. In this way, they are perfect for various civil engineering projects such as wastewater management, drainage systems, and stormwater conveyance. In short, RCC pipes represent the basis of tough and sustainable marine technology, which is the epitome of durability and adaptability, strengthening and prolonging infrastructure solutions. Recognizing RCC technology's full potential will enable professionals to develop innovative and sustainable designs that would enhance the lives of people living in the present and the future. Here are some surprising facts about RCC pipes. Reinforced cement concrete pipes are a crucial part of modern infrastructure, but many people aren't well informed about the amazing features that define them. RCC pipes are designed for long-lasting performance and are manufactured from robust materials. Their durability, 75 to 100 years or more when expertly engineered and properly maintained, is one of the longest lifespans of any material used in contact with water and sewage systems. Their ultimate durability guarantees generations of service, so they form the basis of predictable urban development and environmental monitoring. A significant feature of the RCC pipes is their marvelous flexibility and extraordinary durability. These tubes come built with an inherent fire resistance feature, serving an essential lick in the insulation of either too hot or too cold spaces. Their exceptional ability to resist corrosion helps them to cope with even the most aggressive chemical environments. Thus, they can maintain their structural stability and cannot be destroyed by substances of weaker materials. Besides, RCC pipes have a perfectly engineered design that makes them weatherproof. They can resist hard times like heavy rain, never-ending sunshine, or cold winters. Constructed to be stronger and stronger, RCC pipes take on unusual resistance. Thus, with the smallest fissures, they can cope with the ever-increasing force of floods due to climate change, earthquakes that break the ground, and heavy traffic vessel loads. Their unique ability to change and perform effectively under different circumstances makes them a pivotal front page in improving infrastructural systems, thus ensuring progress and safety in modern everyday life. RCC pipes find applications on premises where many difficulties are faced, such as submarine drainage systems, complex tunnel constructions, and deep sea pipeline projects. These pipes are the most suitable underwater operation options since they are heavy and well constructed. In addition to that, they are also very durable, which is the reason these pipes are used in high-pressure environments. Their sophisticated design aims to protect them from severe external pressures. RCC pipes are the products of a great quality effort that withstands both internal water pressures and external loads, making them indispensable to the infrastructure projects of large-scale water supply systems, highly efficient sewage and drainage networks, and extensive irrigation projects vital for agricultural sustainability. Naturally gaining additional compressive strength over time, RCC pipes have managed to elevate themselves as the best replacement for their metal and plastic counterparts. This is achieved by the continuous hydration of the cement inside the pipes, which leads to an ongoing chemical reaction. In this scenario, these pipes acquire an incredibly high degree of durability and longevity, being more durable as the years pass. Their strength manifests the level of intelligence given to the design and the impact on the water management solutions that are more reliable and durable. Reinforced cement concrete pipes are now becoming the main choice in many infrastructure projects, not only in the construction of durable railway tracks, but also of generous highways and even of tough airport runways. These pipes are the most important parts and components in a good configuration of culverts and drainage systems used as surface support. RCC pipes might be designed so professionally that they deal with the tremendous stresses of fast high-speed traffic and the natural motion of railway vehicles with no damage. It is such great technology that it not only presents a new dimension to the material, but establishes a new level of durability, sustainability, and resilience that is not reached even when the conditions are most demanding. While the creation of reinforced cement concrete pipes involves a certain amount of capital, the negligible level of repair and the long life of the pipes are the main reasons for investing, which saves you money in the end. Moreover, if one observes large projects, RCC pipes seem less expensive than steel and plastic varieties. Therefore, this is a wise decision for the constructors who keep the budget in mind. Besides, they prove to be a wise and money-saving choice since all constraints can be met. Besides the other functions, RCC pipes are heavily relied on to build up the infrastructure of the construction process. Therefore, they both embody strength and sustainability. They are manufactured out of a perfect mixture of natural resources, cement, sand, aggregates, and water, resulting in great performance and the lowest carbon footprint possible, which is a good side effect. These pipes are very nice and practical in green buildings or any construction that follows environmental justice. Reinforced cement concrete pipes are peculiar because of their design, which enables recycling and repurposing by easily incorporating them into various construction projects. This eco-safety elevates recycled or reused products to a new level. This versatility greatly reduces the environmental impact and promotes resource efficiency, demonstrating a remarkable impact on sustainable infrastructure development. Reinforced concrete pipeline products can be used with precast collars of different shapes and joints, designed with a high level of detail to suit every application and operation type. Overall, RCC pipes can be perceived as one of the key components in modern infrastructure technologies, created with sustainable materials and innovative designs aimed at the continuous demands of the city and environmental management. The RCC pipes are now a building block of the infrastructure of smart cities, especially in the fast-paced urbanization situation. With the cities growing and populations rising, these tough pipes play a pivotal role in advanced water conservation and effective drainage systems. These are the main elements of decreasing floods, practicing sustainability in water treatment, and adding hygiene to busy urban areas. So RCC pipes are necessary for urban areas and can greatly impact the ground they serve. RCC pipes are utilized as water carriers and have proven versatile and enduring. Manufactured to deal with dramatic weather changes and extremes like the hot summer and freezing temperatures in winter, RCC pipes are designed to last almost a lifetime with minimal wear out. Thus, this proven dependability serves as the essential substructure for dynamic building infrastructure, compounding the never-ending challenges of modern times. On the one hand, the structural advantages of RCC pipes support sustainable construction activities, indicating that these pipes are irreplaceable elements in contemporary engineering and urban planning. The RCC tubing roadmap emphasizes the laser focus on developing smart urban environments that can thrive amidst the city's new challenges. Mostly, these pipes are not just performing the basic functions they are intended to. They embody long-term plans for prosperous and eco-friendly urban settings. What have you learned about RCC pipes? Share your thoughts in the comments. Thanks for taking the time to watch this video. Before you go, explore the other exciting videos available on your screen.